Good evening, everyone. Welcome back to our session on Python. So we have started understanding the concepts of NumPy, right? In the last class, we understood what exactly is NumPy and the history of NumPy. And we have also understood the concept of, the advantages of using NumPy. Why do we use NumPy? What exactly are the advantages? Right? Next to the advantages, we have understood the similarities and the differences between, the traditional list and NumPy arrays. We have understood both the similarities and the differences. And later on, we have went into the concept of hands-on, where we understood the number of approaches to create an object of ND array. There are multiple approaches, right? So we have understood all the different approaches for creating ND array objects. So what exactly is NumPy, guys? NumPy is nothing but it stands for numerical Python. It was developed in the year 2005 in both C and Python languages. When it comes to the advantages of NumPy, NumPy arrays. NumPy especially deals with the concept of arrays. Okay, so these array objects help us to perform vector operations. We can perform vector operations, whereas we cannot perform the same vector operations on the traditional list objects. So that makes the difference. And they are very fast in execution. And when it comes to the memory consumption, they consume very less memory. So all these differences and the similarities were also being understood. Then coming to the approaches, what are the different functions that we have learnt from NumPy? Before that, what is the syntax for installing NumPy? Guys, what is the syntax for installing NumPy? I want everyone to respond in the chat. Okay, don't sit idle. I want your responses. In order to install NumPy, we have a syntax. It is pip install NumPy. So this syntax, when we execute this command, it installs NumPy. Once after installing NumPy, we have to go with, the importing. Before we use any of the functions that are available inside the NumPy module, we have to import it. Again, what is the syntax? What is the command? The command is import NumPy. Import NumPy. Not just importing, we are also giving an alias name to NumPy as NP. As NP. So this will ensure that not just importing the NumPy, but also we are giving a alias name, a shortcut name for NumPy as NP. Okay, so whatever the functions that we have used from NumPy, when we try to use them, the prefix should be NP dot. It should be NP dot. The reason behind this, we are importing NumPy in this fashion, right? So when I say NP dot array function, did we use array function? Yes. What is the purpose of array function? It helps us to convert any traditional object, any traditional Python object to array. So when I pass any traditional Python object to this array function, this will return me an ND array. Okay, so we have also understood next to array, we have understood arrange function. Yes, arrange function will just take the values like we have three syntaxes for arrange, that is a range of value or a range of start comma stop, or we also have one more syntax, a range of start comma stop comma step. Right. So these are the three different syntaxes that we have used, understood for a range function. And a range function will always return as a 1D array only. What if I want a multi-dimensional array? We have reshape function. When you use this reshape function, okay, when you pass your ND array object to this reshape function, and whatever the specified dimension that you have used for reshape, accordingly it will return as the ND array object, guys. So this is very important, reshape function. And next to arrange, did we discuss zeros function? Yes. What is the purpose of zeros function? Zeros function will return as a zero matrix, either of 1D array or 2D array or n-dimensional array, where all the elements, all the values will be zero. In the same way, we also discussed ones function. All the elements of the array will be 1. Next to ones function, we discussed full function. Right? So depending on the fill value, whatever the value that we specify, okay, so that fill value will be used for giving the values, for coming up the array elements, the array values, this fill value will be used. And finally, we have discussed identity function, which will return as a square matrix. Okay, so that means it will return as a array which is in a similar to square matrix, where all the principal diagonal elements will be 1 and rest of the non-diagonal elements will be 0. Okay, so what are all these functions that we have discussed? All of these are different approaches for creating an n-dimensional array object. In order to build an n-dimensional array object, we have multiple approaches. So all these approaches we have discussed in the last session. Right? We understood 1D array, 2D array. Okay. Then we have also understood 3D arrays. Right? So in today's class, we are going to understand how basic indexing and slicing operations to be done on ND array objects. Because, if you remember the traditional Python objects like list, tuple, set, frozen set, dict, str type. Okay, so on all these different types, we have understood the basic indexing and slicing operations, right? But the difference between array and the traditional Python objects, we understood the difference, right? So in the same way, indexing also will change, guys. The concept of indexing will be very interesting on ND array objects, ND arrays. Okay, so today we are going to discuss the basic indexing and slicing operations followed by advanced indexing. We are aware of basic indexing, that's fine. What is this advanced indexing? So let us understand advanced indexing as well. So this is also called as fancy indexing. Okay, so we'll understand this advanced indexing and how this can be implemented on the ND array objects, followed by, we'll also discuss the arithmetic and matrix operations on ND array objects. Okay, so this will be our agenda for the day. Okay, so pay attention, very, very important topic in Numpy. In the entire Numpy module, one of the important topic is indexing and slicing, as well as advanced indexing. So far, I was referring to the vector calculations. These ND-array objects that we are going to create using NumPy module, they do support vector calculations. So all these vector calculations, you'll understand today. Okay, so I'll just ask you a simple question before I start. What is this? Can you tell me what is this? Come on guys, make it fast. What kind of object it is? What kind of object it is? It's a list object. Good. So my question is, what if I multiply with a int value? Say like, if I want to multiply this list object with a number 2, what will be the output for this, line of code? Can you guess what will be the output for this line of code? Everyone have to respond. Don't sit idle. What happens if I multiply a list object with an integer? What will I get? That is where you majority of us, will fail. It will not return 246. Have you ever tried this line of code? No, this will not be the output. When you multiply any integer with a list object, the values will get repeated, guys. The output will be 123, comma 123. Right? So the output will be in this fashion. You cannot get 246 as output. Very, very important question. See, I just asked you a small question. These are tricky questions. In Python, they'll not trouble you. They'll just question you on the tricky questions. You'll get questions from bit tricky. So your output will not be 246. The output will be repeated. The numbers get repeated. Right? So, but if I take this list and if I convert it as an array, okay, and if I multiply the same array with an integer, will I get 246 as output, or will the values get repeated similar to list? If that is your question, the output will be 246. So this is what called as vector calculation. Okay, if I am multiplying a scalar with a array object, we are multiplying a scalar value with an array object, it allows me to perform the calculation. The vector calculations are possible. Okay, so all these differences we are going to observe in today's session. Right? So pay attention, guys. I'll be questioning you. I want everyone to involve. Okay, because it's completely a hands-on day. Okay, because we are going to learn the concept of indexing and slicing. I want everyone to get involved. Right? So let me directly jump into the hands-on part, because we know what is indexing. Tell me, what is indexing? What do you mean by indexing in Python? Indexing is nothing but accessing a single element. Okay, what is indexing? Indexing is nothing but accessing single element is called indexing. Okay, so let us understand basic indexing. First of all, let us understand the basic indexing on the ND array objects. I'll initially go with 1D array. I'll go with one dimensional array objects, how indexing is performed. Okay? Alright. So what am I doing in line number 223? What am I doing in line number 223? I'm importing NumPy as NP. So before we use any function, any variable or any class from the NumPy module, we have to import it. So that is what I'm doing in line number 223. I'm importing. Okay. I'm importing NumPy and I'm giving an alias name for NumPy as NP. Okay. So let me do it, guys. I'll go, I'll select the line, then I'll execute. Am I done? Yes, the NumPy got imported. What if I get an exception stating that no module found error? If I get a no module found error, module not found error, that means NumPy was not installed. I mean, NumPy was not imported. Okay, so we have to look into that. But here, for me, it got imported. I did not get any exception, right? So I'm done with importing. Then, what am I doing next to it? I'm using NP. What is NP? NumPy. NumPy dot array. The array function that we have discussed. So far, I'm using the array function. For what purpose? We know that array function helps us for converting any traditional Python object. Like in our case, it is list. I'm taking a list object and I'm converting it to array object. So this will return me one dimensional array. This will return me one dimensional array, and that one dimensional array I'm going to store in an object called A. Done. See, A is an array. What type of array it is? It's a one dimensional array. That is why you see only one dimension. 6. What does 6 means? 6 means there are 6 elements, 6 values. Okay. So in this array, what is the maximum value? 60. What is the minimum value? 10. Okay. So for array, you will get the max and min values. Right. What if I want to display it? I'll directly use the object to get to the console. So this is my array object, one dimensional array object. Now, what are we trying to do? We are trying to perform indexing on one dimensional array. What is the syntax in general? For indexing, the general syntax is object followed by index. Am I right? This is what we have done so far. For any traditional Python object, it might be a list, tuple, okay, even what str type object, whatever it might be, object of index. This is the syntax. In the same way, for one dimensional array, the syntax is same. ND array name of index. Okay, so the syntax did not change for 1D array. Now, tell me what will be the output for line number 227 and 228. Because this is quite similar to our, the traditional objects syntax. There is no change with respect to the syntax. Even if you observe, index can be either positive or negative. Index can be either positive or negative. So what will be the output for line number 227, which is A of 0 and 228 A of 3? Your answers. I want everyone to respond. Good. Good. A of 0 is nothing but What is A? A is array. A is representing array object. One dimensional array object, and within this array object I have in total 6 elements. We know that by default indexing in Python starts from 0. If I go from left to right direction, the output, the indexing starts from 0, 1, 2, 3, 4, and 5. What if I traverse in the reverse direction? If I traverse in the reverse direction, the indexing will be -1, -2, -3, -4, -5, and -6. Now, at least now I want everyone to respond. A of 0. Which element do we have at index position 0? It is 10. Which element we have at index position 3? It is 40. Good. The answer is 10 and 40. Perfect. The answers are 10 and 40. Right. So let me execute and cross check whether our answers are right or wrong. So the output is 10, and for line number 228 it is 40. Good. Simple. In the same way, let us go for 2D arrays. 1D arrays are very simple because so far we are doing on one dimensional arrays only. One dimensional objects is what we have learned so far. Now let us try performing indexing on 2D arrays. Okay. So what is the syntax for 2D arrays? Because we know that for 2D array, a two-dimensional array, it contains two dimensions. What are they? Rows and columns. Rows and columns. The syntax is ND array object of row index comma column index. So that means we have to pass two values, guys. For one dimensional array, how many values did we pass? Only one. But for two-dimensional objects, for two-dimensional arrays, okay, we have to pass two values. The first value gives the information about the row index, and the second value gives the information about the column index. Right? I hope it is clear. Now, let me create first of all an array. So this will return me a one-dimensional array. This will return me a one-dimensional array. A is a one-dimensional array. This one-dimensional array, what am I doing? What are we doing in line number 236? I'm using reshape function. I want to reshape array A. Okay, the array that we have A, I want to reshape it to two dimension. What is the dimension that we have specified? 2, 3. What does 2 represent? Rows. 3 represent columns. Okay, so this one dimensional array will be reshaped to two dimensional array. Can you guess what will be the output for B? Keep it on the chart. The output will be 10, 20, 30. So in each row there should be three columns. Done. Then second row 40, 50, 60. Done. So this entire, I'll keep it in a square braces which represents a two-dimensional array. This is a two-dimensional array. Okay. So this is nothing but B. This is nothing but B. Now, I want you guys to respond for 239, 240 and 241. I want the answers for line number 239, 240 and 241. Just map with the syntax and give me the output, guys. Give me the output for line number 239, 240 and 241. because it is very simple, right? B of 0 comma 0. What is B? B is a two-dimensional array. B is two-dimensional array. 0 comma 0. What is the first 0 representing? Row index. First 0 is representing row index and the other 0 is representing column index. Okay. So that means each row will also have an index and each column will also have an index. So this first row will take index 0. Second row will take index 1. First column will take index 0. Second column will take index 1. Third column will take index 2. Now map. Map with the index numbers and tell me the output. 0 comma 0. That means first row, first column. What will be the output? The output will be 10. The output will be 10. In the same way, for the next line, B of 0 comma 1. First row, second column. The output will be 20. Good. For the third line, second row, B of 1 comma 2 means second row, third column, which means 60. So the answers will be 10, 20 and 60. The answers will be 10, 20 and 60. Let me cross check. I'll start executing all the lines. So I'm using reshape function and I'll get a two-dimensional array as output. See, this is my two-dimensional array. Now, how can I perform indexing? It is simple. Just pass the row index and the column index. When you pass both of these for a two-dimensional array, this will return you, the specified value which is at the particular row index and column index. For the first line it will be 10, for the next line it will be 20 and for the last line it will be 60. Right? I don't know why you are not answering, guys. Okay, you have to keep on responding. Answer for my questions. What is the reason behind your silence? Yes, the answers are 10, 20 and 60. So far, we have understood indexing on 1D arrays and two-dimensional arrays. Now let us go and do the same on three-dimensional array. Let us do it on three-dimensional array. So if you observe here, what does the syntax say? Syntax is ND array object of, since we are going to work on three-dimensional arrays, that means we'll have three different values. Each dimension talk about each component. So within the ND array object, the syntax, you have to specify index for the matrix first, then followed by the row index, then followed by the column index, followed by the column index, matrix index, row index and column index. Right? So what am I doing? So I'm creating a one-dimensional array using array function. Okay. Then can you tell me what is happening in line number 248? 248. In line number 248, we are using reshape function. Okay. Where I am specifying that I want a three-dimensional array as output. First of all, will it return me a three-dimensional array? Check. 2 multiplied by 2, 4. 4 multiplied by 2, 8. So, within 8, do we have 8 elements? Yes, we do have 8 elements. So, this will return us a three-dimensional array. This will return me a three-dimensional array. Can you guess what will be the three-dimensional array? Can you keep the pattern? how the three-dimensional array looks like. It will look like 10, 20. Okay. Then how many matrices it should have? Two matrices. Within each matrix, it should contain two rows. Within each row, it should contain two elements, two values or two columns. Right? So this will be 10, 20 and 30, 40. So this will be our first matrix. This is our first matrix. Then second matrix will be 50, 60 followed by 70, 80. This will be our second matrix. Together, it is our complete array. So this is nothing but B, our three-dimensional array. Our three-dimensional array. Now, what am I doing? I am performing basic indexing on the three-dimensional array, guys. What does the syntax is? Index of the matrix followed by the row index, then the column index. Right? So just map with the values of these index values and tell me the output for line number 251, 252 and 253. 251, 252 and 253. For 251, if you observe, what are the indexes that we have specified? 0, comma 0, comma 0. So what is the matrix index? It is 0. Even for matrices also we will have index. Like how we have row index and column index, even for the matrices we have index. So how many matrices we have? 2. The first matrix will take index 0 and the second matrix will take index 1. Okay. Then that means what does 0 represent? It means the first matrix. In the first matrix, again, what is the row index? 0. So there are two rows. The index will be 0, comma 1. And the column index will also be 0, comma 1. In the same way for the second matrix as well, 0, comma 1. Column index will be 0, comma 1. Now map 0, 0 and 0. That means the first matrix, first row, first element. It is 10. Good. The output for line number 251 will be 10. So far it went well because all of these index values are positive. But can we have negative index for the values? Can we have negative values for the index? Yes, we can. We understood, right? Even negative values are also accepted. Right? So what am I doing? In the next line, the question is B of -1, comma 0, comma 0. What does -1 means? -1 is indicating the index of your matrix. But can we have negative value as an index number? Yes. But when? When you go in the reverse direction, if I go from top to bottom, I mean from bottom to the top, the index for the second matrix will be -1. What will be the index for second matrix, first matrix? It will be -2. So this is -1 is representing second matrix. Within the second matrix, I want the element which is at row index 0, that means the first row, and the column index is also 0, that means the first element. So the output will be 50. The output will be 50. And finally for the last question, -2, comma 1, comma 1. What will be the output, guys? -2, comma 1, comma 1. What is -2 representing? The first matrix. So this matrix 1, comma 1 means first row, I mean the second row and second column. which means 40. So check whether you have answered for these three questions as 10, 50 and 40. If you have answered 10, 50 and 40, yes, you are right. You are right. Okay. So this is how we perform indexing. This is whatever we have understood so far is nothing but basic indexing on, ND array objects. One dimensional, two dimensional and three dimensional. Right? So let me execute these lines. So I'm using reshape function to get a three-dimensional array, and this is my three-dimensional array. Okay. Now I'll execute these lines one by one. For the first line, I should get the output as 10. Yes, I'm right. And for the line number 252, I have to get the output as 50. Yes, I'm right one more time. And finally, for the last line 253, the output should be 40. The output should be 40. Clear? Any questions? I hope it is clear. Now, let us enter into the concept of advanced indexing. Basic indexing is very simple. If you are clear on the syntax, it will be very simple for accessing any value, any single value of n-dimensional array object. Right? If it is one-dimensional array, we'll just pass only one single value. If it is two-dimensional array, we'll pass two values. Row index, column index. If it is three-dimensional array, we have to pass three values. Matrix, index of the matrix, then row index, and then column index. Now, let us understand the concept of advanced indexing in Numpy. So this is very important, guys, because so far you consider any Python traditional object. Okay. Did we work out on advanced indexing? No. We just understood only the concept of basic indexing. But NumPys, they do support, they do support advanced indexing. What is the concept of advanced indexing? Advanced indexing is nothing but, accessing multiple elements. When you want to access multiple elements, but these elements, if they are not in a specific order, what? I know the concept of slicing, because slicing means accessing multiple values, but these values also should be in a particular order. Then we can go with the concept of slicing. Am I right? Do you remember the concept of slicing, guys? Yes. In NumPy, we have a concept of advanced indexing which allows us to access multiple elements. But these elements may or may not present in a particular order, but still we can access them using the concept of advanced indexing. How can we access these elements which are not in a specific order? Is we'll specify some condition. Based on some condition, we are going to access these multiple elements. So shall we go and understand the concept of advanced indexing? Yes. So let me start. I'll start with one-dimensional arrays. First of all, I'll go with one-dimensional arrays. Okay. So this one-dimensional array on one-dimensional arrays, let us understand the concept of advanced indexing. The syntax is again same. Okay. N-dimensional object. It's nothing but the array object, n-dimensional array object. Within the object, you are passing some x. What is this x is? X can be either an array or list. It can be either array or list object which represent the index values. Which represents the index values of the elements that you want to access. Probably you may not understand. So let me take an example so that it will be very clear. So I'm taking a small example here. What is this? What do we have in line number 269? I see this is a list object. Am I right? Yes. This is a list object of size 9 because all the elements are organized in square braces. So this should be a list object. Let me check. Yes. LST is a list object of size 9. What am I doing? I am converting this list object into a one-dimensional array using array function from Numpy. Okay. Where am I storing it? In a variable A. In an object A. Done. And this is my one-dimensional array. This is my one-dimensional array. Now, what if I want to access elements like, what am I trying to access? 10, 30 and 80. 10 is at index 0, 30 is index 2 and 80 is somewhere. Okay, so within this array, one-dimensional array, do you see these elements at regular intervals? No. They don't follow specific order, but still I can access these elements. I can access multiple elements in this way using the concept of advanced indexing. How? First of all, capture the indexes of the elements that we want to access. So what are the indexes of 10, 30 and 80? They are 0, 2 and 7. They are 0 because by default we know indexing starts from 0. Okay, so 10 will take an index 0 and 30 takes index 2 and 80 takes index 7. So I have captured all the index values and I have stored them in a list object. Yes, list object because we can pass a list also. Okay, I can pass a list or an array. Both are accepted. Now, this list object, the list I have with the indexes, I am converting it to a one-dimensional array again. Okay, using np.array, what am I doing? I am converting this list to array. So where am I storing this one-dimensional array? In a variable called indexes. So let me execute the code till here. So I have created the list object with indexes. Then next to it, the list object that we have, I am converting it to a one-dimensional array object. See, if you see, indexes is an one-dimensional array object. And I am printing the array object. So this is my array object. Now I'll just follow the syntax of advanced indexing for 1D one-dimensional arrays. What does it say? Array object. What is array object that we have? It is A of, within the square braces we are supposed to pass either an array or a list object. What am I passing? I am passing a array object. Indexes is an array object. So if I pass A of indexes, this will return me only 10, 30 and 80. You see here? So that is the concept of advanced indexing. You need not pass, these elements. If you observe carefully, 10, 30 and 80, they are not in the same order. They don't follow any order. But still I am capable of accessing them. That is how, using the concept of advanced indexing. So here I have passed an array, one-dimensional array. What if I pass a list object directly? See, I am capturing all the indexes of 10, 30 and 80 in a list. See, 0 to 7, I have stored them in a list object. See, and can I directly pass it to, can I directly pass? Yes, I can directly pass. Either list is also accepted. So A of the list object. What is the list object? I and D. IND stores the indexes of the elements 10, 30 and 80. So when you say A of IND, this will return me 10, 30, 80. 10, 30, 80 will be returned. And finally, what if I don't directly, assign the values? Here I am assigning to, I'm storing the indexes to a list object. Then I am assigning that list object inside I'm using the list object for passing. But what if I don't assign and pass? If I directly do it, is this also fine? Yes. Whatever the matter doesn't, no, it doesn't matter. The output will be same. The output will be same, guys. It will be 10, 30 and 80. So either you pass an array object or list object. Okay. If not, you directly pass the list as it is. So this is the concept of advanced indexing. So if you have understood, can you tell me how can I access the values of 20, 30, 80, 10, 10, 30 from this array? From this specific array, I want to access elements like 20, 30, 80, 10, 10, 30. Is there any specific order between these elements? Do you find any order, guys? There is no kind of order, right? But still, how am I able to do it? I'm able to do it because of, advanced indexing. So I'm creating a list object initially. So this is my list object. I have the list of elements. All of these are int values, right? So in total, how many values we have? There are 9 values. And this list object is being converted to array. I'm converting the list object to one-dimensional array. So this one-dimensional array I'm storing in A. I'm storing in A. So when I do it, what happens? This will return me a one-dimensional array. So I'll execute line number 286. List object got created. Now the list gets converted as an one-dimensional array and I'm storing in A. So this is my array A. As I want to access the elements of 20, 30, 80, 10, 10 and 30, first of all, we know that we have to get the index values of these elements. We have to get the index values of these elements. What is the index of 20? It is 1. What is the index of 30? It is 2. What is the index of 80? It is 7. Index of 10, 10 is 0. Again, anyhow it is 10, it is 0. So for 30 it is 2. I have captured all these index values in a list object. See. Now this list object I'll use as part of advanced indexing so that it allows me to access all these elements. Very simple, guys. If you observe carefully, advanced indexing is very simple. Until unless if you understand the syntax. So for one-dimensional array, what does the syntax say? The syntax says the array object of either you pass a list or again you can also pass array. You can also pass an array object where it contains the index values of the elements that you are trying to access. Right? So let me execute line number 290. And finally, this will return me line number 291 will return me the required elements. It will return me the required elements. So this is how we perform advanced indexing on 1D arrays. Let me go to 2D arrays. What happens in case of 2D arrays? In case of 2D arrays, the syntax is the array object of, as we are working on two-dimensional arrays, we'll have two dimensions. One is rows and the other one is columns. So we have to specify row indexes and column indexes separately. Row indexes, all row indexes in the first square braces, then followed by all the column indexes in the second braces. Okay, so this will be the syntax for advanced indexing in case of two-dimensional arrays. Let us work out on a few examples. What am I doing? I'm importing Numpy as NP because I'm trying to use some of the functions from Numpy. Okay, then what do I have? Okay, I see a list. It is a nested list that I am passing to the array function. Okay, so which contains four nested lists. See, 1, 2, 3, and 4. Okay, so I have nested list. I am passing it to the array function. This will return me a two-dimensional array. Can you guess what will be the size of this matrix? What will be the size of this matrix? Come on, guys. It will be 4 by 4. Why 4 by 4? There are 4 rows and 4 columns. Okay, so this will be my matrix. This will be my matrix. Now the question raises. Yeah, it's not actually 1, 4, it will be 4 by 4 because it's a two-dimensional array, right? So it will be 4 by 4. So what is the question that we have here? I want to access the elements that we have in the principal diagonal axis. Okay, what are the elements that we have in the principal diagonal axis? We have 1, 6, 11 and 16. Okay, so these are the elements that we have in the principal diagonal elements, principal diagonal axis. How can I access these elements? Okay, if that is your question, we have the concept of advanced indexing. In general, can you use basic indexing to access these elements? Just think. From a two-dimensional array, by using the concept of basic indexing, can you access these elements or not? What do you say, guys? What did we learn as part of basic indexing for, you know, two-dimensional arrays? It allows us to access only one element. If we observe, I can access only one element. But here, using advanced indexing, what I'm trying to do, I'm going to access multiple elements which are not in a specific order. I'm going to access 1, then 6, 11 and 16. How? I'll just use the syntax of advanced indexing. See, what I'm trying to do is, I'll specify all the row indices and column indexes both of all the elements that I'm going to keep. So first of all, what is the first element? 1. What is the row index for 1? 0. What is the column index for 1? 0. So that means the row index should be 0 and followed by the column index also should be 0. Right? So this is how the PVM, the Python virtual machine, it understands so that 0 comma 0 means it means 1. Okay. So all the row indices for the element should be kept in one square braces, and in the next square braces we have to keep all the column indexes. What is the next element? 6. What is the index, row index for 6? It is 1. Column index will be also 1. So 0, comma, row index for 6 is 1. Column index is also 1. In the same way for 11, it is 2, comma 2. So I'll just specify as 2, comma 2. For 16, it will be 3, comma 3. So I have to keep it here as 3, comma 3. So these two square braces, if I go and keep in my syntax, see, are these same? Yes. How did we get these square braces? This one and this one. The first one is representing the row indexes of the elements, and the second square braces is representing the column indexes of the elements. Okay. So when you run this line of code, the PVM understands, it takes both the list objects and it understands the elements that we have at 0, comma 0, 1, comma 1, 2, comma 2, and 3, comma 3. In that way, it will retrieve us the values like 1, 6, 11 and 16. I hope it is clear, guys. Right? So let me go with the execution. So when I execute this line number 301, it will return me 1, 6, 11, 16. See. Done. In the same way, tell me, how can I access the elements like 6 and 14? Try from here. This is the two-dimensional array that was provided to you. How can I access elements like 6 and 14? Can I access 6 and 14 from this two-dimensional array matrix? Yes, I can. I can. How? Using the concept of indexing, advanced indexing. Right? So, it's very simple, guys. See, what does the syntax is? All the row indexes of the elements. See, understand this example. See, I'm trying to access elements like 6 and 14 from this two-dimensional array. First of all, will you agree this is a two-dimensional array? Is this a two-dimensional array? Yes. Tell me the size of it. 4 by 4. 4 rows, 4 columns. Two-dimensional array is what we are working on. From this two-dimensional array, I want to access elements like 6 and 14. 6 and 14. Okay. So, how can I access 6 and 14 will be a question. First, get the indexes of 6 and 14. The index, row index for 6 is 1. Column index is also 1 because by default index starts from 0. Right? In the same way, tell me the row index for 14, it will be 3. But column index will be 1. Right? Now, take all the row indexes for the elements. The row index for 6 and 14 are 1, comma 3. 1, comma 3. Now, coming to the column indexes. What are the column index for 6 and 14? It is same. 1, comma 1. Both 6 and 14, they belong to the first column only. I mean the second column where the index is 1. Okay. So when you keep your row indexes and column indexes, when you execute this line, what happens is PVM internally takes the elements of 1, comma 1. What is the element that we have at 1, comma 1? It is 6. What is the element that we have at 3, comma 1? It is 14. Okay. So this first square braces talks about row indexes. The second square braces gives the information about column indexes. I hope it is clear now. That is how, that is why I'm asking you to understand the syntaxes. So even if you see here, what is our array object name? It is mat. Mat is our array object name. Mat of, within the square braces, we have to provide both row indexes and the column indexes. So this will return me 6 and 14. Let me execute this. What is the output? 6, 14 is the output of line number 306. Is it clear now? It is very simple. If you understand the syntax, it is very simple. Clear? Right. So we have understood the concept of advanced indexing on 2D arrays. Let me go for 3D arrays. Three-dimensional objects. Okay. Right. The syntax will be seen, but additionally, you will have one more square braces. What does the first square braces talk about? The indexes of the matrix, followed by the row indexes and the column indexes. Already we are aware of row indexes and column indexes for 2D matrix. In the same way, additionally, one more square braces will be added, which gives the information of the matrix index. So if you are working on a three-dimensional array, and if you want to perform, if you want to access multiple elements where there is no specific order between these elements, then you can go and perform advanced indexing using this syntax. Okay, here if you observe, I am creating a three-dimensional array. What am I doing? First of all, I am going to import numpy as np. Done. Then I have a list object. It's actually a nested list object with 24 elements. Done. The size is 24. Okay. So actually it is 2. The reason behind is the list object contains only 2 square braces. Within the square braces there are again 3 square braces and 3 square braces. Within the square braces we have elements. Right. So this list object I am converting to array object. I am converting to array object using np.array. So this will return me a three-dimensional array. Can you guess what will be the size? What will be the shape of mat 3D? What will be the shape of mat 3D, guys? How many matrices will it form? 2 matrices. This will be, all of these elements will be one matrix, and the line number 314 elements will be of matrix 2. Then each matrix will contain 3 rows. Each row will contain 4 columns. So that means the size of mat 3D will be 2, 3, 4. See, let me do it. Let me print the output. So this is my three-dimensional array. 2 matrices, each matrix with 3 rows and 4 elements in each row. So when I say mat 3D of ndim attribute, this will return me what type of array it is. We know it is a three-dimensional array, so the output should be 3. And when I say mat 3D dot shape, it will return me what? It will return me 2, 3, 4. 2 matrices. Each matrix contains 3 rows and each row contains 4 elements. Is what? That is how you have to interpret the size, the shape of any given n-dimensional array object. Right. From this 3-dimensional array, I want to access the elements of 1, 14 and 24. 1, 14 and 24. Where do we have 1? In the first matrix. Where do we have 14? In the second matrix. Where do we have 24? In the second matrix, the last element. So these are the elements that I want to access. How can I do it, guys? I can do it using the concept of advanced indexing. Right? So if you observe carefully, for three-dimensional array, the syntax is, first of all, let me give the indexes for both of these matrices. So this matrix will take the index as 0 and the second matrix will take index as 1. Right? For these elements 1, 14 and 24, let me specify the row index and column index as well. So here for 1 it is 0 and 0. Row index is 0 and column index is also 0. Coming to 14, row index is 0 but column index will be 1. Coming to 24, row index is 2, column index is 3. 0, 1, 2, 3. Now, I have all the indexes of the elements. Let me, frame my line of code. Okay. So what should be kept in the first square braces? The indexes of matrix. The elements to which matrix they belong to. So 1 belongs to which matrix? 0, comma. Then 14 belongs to 1, comma. 24 belongs to 1. So this is the first square braces which represent the index of matrices, comma. Then the second square braces should have the information about the row indexes. So again come back. For 1, what is the row index? 0, comma. For 14, the row index is 0. For 24, the row index is 2. Done. In the same way, the column indexes for the three elements 0, 1, 3. 0, comma 1, comma 3. So if I try to access all these elements, if I'm accessing the elements like 1, 14 and 24, I have to specify these index values of matrices, rows and columns. Only then this will result us in the output of 1, 14 and 24. That is how you are going to access the values of 1, 14 and 24. You cannot access the values of 1, 14 and 24 by using basic indexing. This is the concept of advanced indexing, which is possible in Numpy. Okay. Right. So let me do it, guys. Let me do it. Before I erase the content, let me execute and cross check whether I am getting the same output or not. Yes, the output is same. The output is 1, 14 and 24. I am able to access. I hope it is clear, right? Yes. Now, coming to one more question. I want you guys to answer this question. Okay. I want to access elements like 10 and 16. Okay. I'll keep the answer closed for some time. And I want you guys to answer for how to access the elements of 10 and 16. So using this syntax, you have to keep your answers in the chat box. Keep it in the chat. How can I access the elements like 10 and 16? Let's see how many of you are going to do it. Give a try, guys. I want everyone to try at least. So what will be the output? What are we trying to access? 10 and 16. Yeah, as usual, do the same process. So this is matrix 0, index 0, and the second matrix takes index 1. Then capture the row indexes. For 10, the row index will be 2. For 16, the row index will be 0. Then column indexes. For 10, the column index will be 1. For 16, the column index will be 3. Careful. See, that's what. When you're keeping your answer, as we are working on a three-dimensional array, we should have three matrices. I mean, three square braces. Right? So somewhere you have missed. Try it. Try it one more time. So it will be like 0, comma 1, comma, then coming to the rows, 2, comma 0, comma, then finally the column indexes, 1, comma 3. Done. It's very simple if you understand the syntax. If you understand the syntax, you can answer any question. That is what I'm telling you from starting. So this will be the, indexes for the matrices, rows and the columns. See, even I'll reveal the answer. Check. Okay. So here it was done in using the negative indexing. Let us also understand the negative indexing, guys, because this is also important. Right? So what does minus 2 means? Minus 2 means the second matrix. Okay. So this can be also written as minus 2. Sorry, my bad. So this will be minus 1. As I'm going in the reverse direction, minus 1, minus 2. So what is the first element that we are accessing? 10. Minus 2, comma, minus 1. Then for rows, as I'm going in the reverse direction, this will take minus 1. But for 16, if I go in the reverse direction, it will be minus 3. It will be minus 3. Good, good. Keep it up. And for columns, for 10, as I'm going in the reverse direction, minus 1, minus 2, minus 3 for 10. And for 16, it will be minus 1. So, this negative index is what we have used, and we are accessing the elements like 10 and 16. Either I can do it using positive index or negative index. No matter what, the output should be 10 and 16. Right? So, when I execute line number 327, this will return me the output as 1016. Clear? Yes. Right. So one more example, but this time it is related to four-dimensional arrays. 4D array. So far we understood one-dimensional, two-dimensional and three-dimensional. Let us also work out on four-dimensional arrays. So what am I doing here? This is four-dimensional. Not exactly. Okay, next to the example. Okay, fine. So this is a list object I have. I'm coming up with a list object. Okay, and this list is being converted to an array. So this will return as a three-dimensional array only, guys. My bad. Three dimension. Two matrices, and each matrix contains three rows, and each row contains four elements. So it is three dimension. Fine. Now, instead of specifying, every time, I want to access the elements like 1, 8, 13 and 20. Okay. So we know that we have followed the syntax of advanced indexing by providing the indexes of matrices, rows and columns. But what am I doing here is I'm capturing the indexes as tuple object, and then I'm storing it to a object. Okay. So this tuple object is what I'm using in the syntax. Is that allowed? It is not possible, right? Both matrices will have same number of columns. How can you say that they'll have different number of columns? That is not possible, right? So far, if you are observing, did you get any example where, you know, you have noticed any of the matrices have two different columns, the two different number of columns? No. How you are defining? Okay, it will not allow us to have different number of columns, right? So I'm just keeping all the indexes of matrices in a tuple object. Then for rows and for columns. So I'm passing these inside the, I'm passing all of these three inside our syntax. A of indexes, row indexes, column indexes. This will return me 118, 1, 8, 13 and 20. Either you do in this way or this one. Anything is accepted. At the end, it should satisfy the syntax. Right? Fine. Can you tell me what will be the output for this line number 340? I'll give you, good amount of time. By understanding the indexes, tell me what will be the output for line number 340. A of, it is very clear that this syntax is indicating advanced indexing. How? As we are working on a three-dimensional object, I also see three square braces where each square brace represents about matrix indices. The first one is index, it is talking about the indexes of the matrices, and the second one is talking about the indexes of the rows, and the third one is talking about the indexes of columns. Now, by looking at these indexes, I want you guys to answer the question, what will be the elements that we are trying to access from line number 340? Everyone have to respond. What will be the output, guys? Simple. 0, you take all the three corresponding values. 0, 0, 0, which means 1, because zeroth matrix, how in the zeroth matrix, in the first matrix, the first row, the first column element is 1. Then go to the second one, 0, 1, 1. Again, the same first, first matrix itself, but the row index is 1. That means the second row, the column index is also 1. That means second column, which means 6. Then 0, 2, 2 means 0 means, again, it means first matrix. 2, 2 represents third row, third column. It means 11. Then in the same way, do the same for the last three columns. The last three values, you'll get the values like 13, 18 and 23. 13, 18 and 23. So that means I'm trying to access the elements like 1, 6, 11, 13, 18 and 23. Let me execute, guys. Let me cross check whether I'm trying to access the same. Yes. See. 1, 6, 11, 13, 18 and 23. Clear? Right. Fine. Now let us work out on 4-dimensional arrays for some time. Okay. So what I'm trying to do here is I'm taking a one-dimensional object list. Okay, so I have a list object and I'm using np.array function, and I'll convert this list object to array object, one dimensional array object. So I'm printing it. This is my array object. What is the size of A? It is 16. There are 16 values, 16 elements inside the one dimensional array object. What does it mean? What does it mean? We know A dot shape will return us the shape of A, right? But we have specified the shape. That means I want A to be converted to a four-dimensional array. You see here, there are four dimensions. 1, 2, 3, 4. Okay, first of all, will it allow us to reshape? Let us check. 2 multiplied by 2 is 4. 4 multiplied by 2 is 8. 8 multiplied by 2 is 16. Do we have 16 elements? Yes, I do have. So that means I can convert this one-dimensional array object A to 4D array. This is possible. This is possible. And this will return me a four-dimensional array where the 2 represents the column number, the second 2 represents the row number, and the third one represents the matrices number, whereas the first 2 represents the block number. The block number, this is very important. Number of blocks, within each block how many matrices we have, within each matrix how many rows we have, within each row how many elements or how many columns we have, is what is giving the information. Okay, so this is how you represent a four-dimensional array. And greater than 4D arrays, it contains blocks. Even though if you go for 5D, 6D, all of them, they contain blocks only, guys. Okay, so this is the constant. Right. So what I'll do, I'll go and execute the line. So this will return me a four-dimensional object. See. So I have two blocks. First of all, this is block 1 and this is block 2. Within each block, do you have two matrices? Yes, this is matrix 2 and these are two matrices. Each matrix should contain two rows. Yes. Yeah, every matrix contains two rows. And each row should contain two elements. Clear? Now let me access elements from this four-dimensional array object. This is again basic indexing, because I'm just accessing only a single element. If you observe properly, I'm accessing a single element, A of 0. That means the first block. Then within the first block, which matrix? The first matrix. Within the first matrix, which row? First row. 0 represents the first row. Within the first row, which element? The first element. So the output will be 10. I hope you have understood. How did we get 10? Should I repeat one more time? See, the first 0 represents block, the block index. The second 0 represents the matrix index. The third 0 represents the row index. And the fourth 0 represents the column index or the element index. So this is my first block. Okay, within the first block, this is my first matrix. Within the first matrix, this is my first row. Within the first row, this is my first element. So the output is 10. That is how we are accessing element 10 from a four-dimensional array object A. Clear? Right. Now, let me access elements like 10 and 40. But if you observe carefully, as I am accessing elements like 10 and 40 from this 4D array object A, I don't see there is a particular order. There is no particular order followed. So what has to be used? We have to go with the concept of advanced indexing. What does advanced indexing says? Just pass the indexes. Whatever the elements that you are trying to access, all these element indexes you have to, the element indexes has to be passed in such a way that as we are working on 4-dimensional array objects, initially we have to pass the indexes of the block, then the indexes of the matrix, then the indexes of the rows, then the indexes of the columns. Right? So let us pass all of these. What are the elements that we are trying to access? 10, 40. Okay. So first of all, the block indexes for 10 and 40 are same. Both of them, they belong to the same block. This is block 0. Block index 0. So the index for the blocks will be 0, comma 0, comma. Coming to the matrix, to which matrix they belong to out of 2? They belong to the first matrix. The first matrix takes index 0. Both of them, they belong to first matrix only. So the index will be 0, comma 0 again, comma. What about the row index? Rows are different, guys, because 10 belongs to first row, which takes index 0, whereas 40 belongs to row index 1. So the next values will be 0, comma 1, comma. What about the column indexes? 10 belongs to column index 0 and 40 belongs to column index 1. Final values are also 0, comma 1. When you pass all of these, okay, within the syntax, and if you are able to access them, this will return me 10 and 40. This will return me 10 and 40 from, the 4-dimensional object A, the 4D array object A. So let me execute and see what it is going to return me. For sure, it will return me 10 and 40, guys. See? And one last question. I want you guys to try this. Okay. So how can we access elements like 60, 55 and 15? 60, 55 and 15. Will you do it? This is 60, 15. Sorry, the second number is 55. The second element that I want to access is 55 and the third element is 15. Will you do it and tell me the answer? What will be the indexes for the block, matrices, then rows and columns? I have specified the entire 4D array object. I want you guys to give a try. So what will be the output? Anyways, I am disclosing the answer. Good. The block values will be 0, 1, 1. Perfect. The reason why is 60 belongs to block 0, whereas 50 and 55, they belongs to 1. So the block values will be 0, comma 1, comma 1. What about the matrices? When it comes to 60, in the first block, okay, it belongs to the second matrix. So the matrix index will be 1. What about 55? 55 also same. It belongs to second matrix of block 2. What about 15? It belongs to the first matrix of block 2. Okay, so the matrix indexes will be 1 comma 1 comma 0 comma. Coming to the row indexes, if you observe 60 is at first row, index will be 0. 55 is also at index 0, first row. 15 is also at index, the first row, the index will be 0. Coming to the columns, column index, 60 is in second column, which means index will be 1. Whereas 55 and 15, both of them are in the first column itself. So the index will be zeros. So this will return me values 60, 55 and 15. This is how you can access any number, any element from n-dimensional objects, n-dimensional array objects. The process is seen. If you understand the syntax, I'm telling you, if you understand the syntax, any question, whatever might be the size of the array, okay, you can answer the size, you can answer the question, right? So this is how we perform advanced indexing advanced indexing using Numpy. The next topic that we have is slicing. So far, we just understood the concept of indexing only. Okay, we understood indexing only, guys. As part of indexing, we understood both basic indexing and advanced indexing. But now, let us go with slicing operations. Do you guys remember slicing, first of all? What is slicing? What do you mean by slicing? Slicing is nothing but accessing multiple values, a range of values, a group of values, right? So let us understand how slicing can be done on different types of array objects. So we'll work it on one dimensional, two dimensional and three dimensional array objects. Okay. So what I'm doing here, first I'll go with one dimensional array object. Okay. The syntax is very simple. It is similar, right? We have begin colon end colon step, similar to our one dimensional objects like list, tuple, right? So all of these syntaxes it's not new for us, right? So what I do is I create a one dimensional array object. First of all, I'm importing numpy and I'll use array function to create a one dimensional array object. A list object is what we are using and creating a one dimensional array. Done. So this is my one dimensional array of size 7. There are 7 elements in it. Now, what are we doing in line number 364? Don't assume this is indexing, guys. When can you assume it is indexing? When you don't find this colon symbol. But when you see colon, it means it is slicing. I did not pass any value for begin and end. I did not pass any value for begin and end, but step takes the value as -1. When you are going with the negative step value, it means in the reverse direction we have to go. We have to go in the reverse direction. As I did not specify the start, the begin index and the end index, it means the entire array object will be printed in the reverse direction. It returns in the reverse direction. See? You remember slicing operations that we have done on the traditional Python objects. List, tuple, str type. bytes, byteary, right? So we are doing the same. But what got changed is we are doing now on array objects. Then next to it, I'm going to go for one more example where I did not specify start, the begin, end, and step. As I did not specify any of these values, that means the entire one-dimensional array object will be printed as it is. As it is. Right? The reason why we did not have multiple examples is we are already familiar with the slicing operations on one-dimensional objects. Let me go with two-dimensional arrays. Let me go with two-dimensional arrays. If you observe the syntax for two-dimensional arrays, it is like n-dimensional array object of I comma j. I comma j. What does it mean? It means I represents the row index and j represents the column index. I represents the row index and j represents the column index. Okay. So either if you can specify in this way in general, if not, you can keep it in this fashion. Row index comma column index, or for rows if you want to specify with this colon, okay, begin colon end colon step. So all of these are for row index, for rows. In the same way for columns also you can specify begin colon step end colon step. Anyone can be used. Okay. So let me try it on example. What am I doing here? I am coming up with an array object. Okay. But this will be a two-dimensional array. This will be a two-dimensional array. Let me print the array. So if you observe, we got a matrix. What is the size of the matrix? 2 by 3. 2 by 3. 2 rows, 3 columns. So can you tell me what will be the output for line number 376? 376. A of 0 comma 0. When I say A of 0 comma 0, what is the first 0 representing? The row index. The second 0 represents the column index. Right? So row index is 0, column index is also 0. So what is the element that it will be returned? The output will be 10. The output will be 10. In the same way, tell me the output for the next line. Here I am using the concept of slicing. Good. A of 0 colon comma 0 colon 1. Everyone have to give a try and I want the answer for line number 377. What will be the output for line number 377? A of 0 colon comma 0 colon 1. So the first part, whatever we have, this is for rows. And the second one is for columns. So when I say 0 colon, that means I began with 0. Right? Do I have any end? No. There is no end. That means I have to consider all the rows. Starting from the first row, the index, row index 0 till all the rows. That means I have to consider both the rows. But coming to the columns, I have to start with column index 0 Then where should I end? It says 1, but we know we have to end at n minus 1 itself. If you observe, if you remember the concept of slicing, whatever the end value that we have, the sequence should be ended at n minus 1 value only. So what is n minus 1 value? It is 0. So that means I have to stop at the column index 0 itself, which means only the first column. So what will be the output for line number 377? All rows, but only first column. What will be the output? What will be the output, guys? It will be 1040, the first column. The first column will be written as it is. Then I'll go to the next example. 0 colon, comma 1 colon 2. What will be the output for the line number 378? 0 colon means both the rows. Starting from the first row, it has to go till the last. So that means all the rows. But from which column? From column 2. Because the index is 1. The first column takes index 0. Second column takes index 1. But where should I stop? Where should I end? 2. 2 minus 1 will be 1. So that means only the second column. Only the second column will be the answer for line number 378. And finally, for the last line, 1 colon, comma, colon. What will be the output for line number 379? One colon means it has to start at directly the index, row index 1. This is 0, right? This is 0. So it has to start directly with the second row. But did we specify any column? No. As we just specified only colon, it means consider all the columns. So the output will be the entire second row. 40, 50, 60 will be given as output. See? The entire second row will be written as output. Clear? Let me also perform slicing on three-dimensional arrays. We understood slicing concept on one-dimensional, two-dimensional, and let us apply it on three-dimensional arrays as well. So when it comes to three-dimensional arrays, obviously we'll have three dimensions, right? So I, J, and K, where I represents, the matrix index, and J represents the row index, and K represents the column index. See, matrix index, row index, and column index. So obviously you can have three, begin colon, end colon step defined for all these indexes. You can define all of these as per the matrix index, row index, and the column index. Right. So let me first of all create a, so I'm going with a list object. So this is a nested list, okay, which contains only two elements, which means two lists in which we have inner list. So I'm printing the list object. This list I'm converting to array. So this will return me a three-dimensional array. It will return me a three-dimensional array. Where am I storing this three-dimensional array? I am storing in an object called ARR2. ARR2. So let me store it in ARR2. So what is the size of the array? It is 2, comma 3, comma 3. What does it mean? It means two matrices, three rows. Each matrix contains three rows and each row contains three elements. Nothing but three columns. Right? I'm printing this array, three-dimensional array to the console. Let me do it. See? So this is my three-dimensional array. Two matrices, matrix 1, matrix 2. Each matrix contains three rows. Yes. Each row contains three elements. Yes. So the size is 2, comma 3, comma 3. When I say array.ndim, the array object.ndim, it will return me the output as 3 because it's a three-dimensional array. And if I go with the shape attribute, it will return me 2, comma 3, comma 3. Two matrices, three rows and three columns. Fine. Let me perform the slicing operation on the three-dimensional arrays. I want you guys to involve and tell the output for line number 398. For line number 398. What did we specify? It is colon, comma, colon, comma, 0, colon, 1. The first one is for matrices. The second one is for rows. And the third one is for columns. So by looking at this, tell me the output for line number 398. Give a try, guys. What does colon means? Did I specify begin and end? No. That means it will consider both the matrices. Matrix 1 and matrix 2 will be considered. Okay. It's better if I represent this index matrix 0 and matrix 1. Matrix index 1 and matrix index 0. Both matrices will be considered. And within the matrices, how many rows should be considered? All the rows also should be considered because I did not specify any begin and end. I just kept it as colon. When I specify colon, it means to consider all the rows. So 0th row, index row, 0th index row, row index 1, row index 2 should be considered from matrix 0. And in the same way from matrix index 1, row index 0, row index 1, row index 2 should also be considered. Then coming to the columns, I have specified the values. The begin is 0. That means it has to begin with the column 1. What does 0 means? 0 index is nothing but column 1. Right? So it will begin with column 1. But where it should end? It should end at column 1 only. We know that end value is 1. We know that it also should end at n minus 1 value. 1 minus 1 is 0. So it will end at the first column itself. So what will be the output for line number 398? What will be the output for line number 398? No, 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 no. It will return as the entire first column from both the matrices. From both the matrices, it will return both the first columns. See, why it is 1 or 4, guys? Understand? From both the matrices, I want the elements. That is what we have mentioned. From all the rows is what we have mentioned. But coming to the columns, we want only the first column values. See. So the output will be the first column from both the matrices. Let me execute and show you the results. See. 1, 4, 7, 13, 16, 19. Making sense? Yes. So whatever we have understood, by applying the same knowledge, try answering the next question. Colon, comma, colon, comma, colon 1. Colon, comma, colon, comma, colon 1. If you observe properly, line number 398 and 399 both are same. Line number 398 and 399, whatever we have defined for the indexes, okay, all of these are same because both the matrices, all the rows, but coming to the columns, by default, if you don't pass anything for the start value, the begin value, it starts from 0. So the output will be again the same. The first column from both the matrices. The first column from both the matrices. Right? Try responding for answer line number 400. Answer line number 400. Colon, comma, 0, colon, 2, comma, 1, colon, 3. What will be the output? When I say colon for the matrices, that means from both the matrices. Because I did not specify anything for the matrices. I just specified as colon, which means to consider all the matrices. Okay. But for rows, I just specified as 0, colon, 2. I specified it as 0, colon, 2. It starts from 0, then it goes to 1. It will stop at 1. It does not go to 2. So that means from both the matrices, it has to take only the first two rows, the index, row index 0 and row index 1. Row index 0 and row index 1. Only these two will be taken. Fine. What about columns? 1, colon, 3. 1, colon, 3. What will be the output for 1, colon, 3? 1, colon, 3 means it will start at 1 and then 2. Will I have 3? No. It will end at 2 itself. So that means from both the rows, okay, it should start at column index 1 and it should go till column index 2. Okay, so this is what I'll get as output. In the same way, this matrix is what I'll get as output. Making sense? So the output will be 2, 3, 5, 6, 14, 15, 17, 18. Let me execute this. See. 2, 3, 5, 6, 14, 15, 17, 18. One last question for the day. What will be the output for line number 401? Colon, comma, colon 2, comma, 1, colon. Which means both the matrices. So this is also same 0. When I don't specify anything from the begin, by default it takes 0. Right? And here I'm not specifying anything for end. We know that we have only 3 columns. So the output will be same. Line number 400 and 401 will return us the same output. Observe it carefully. Is the output same? Yes, it is same. So this is how, we perform slicing on one dimensional, two dimensional and three dimensional arrays. So that means we can perform slicing operations on n dimensional objects as well. Yes. Okay. So we have understood what did we cover so far is in today's session we understood the concept of indexing. As part of indexing we understood basic. Under basic we understood on 1D, two-dimensional array and three-dimensional array. Next to the basic indexing we understood the concept of advanced indexing. Under advanced, again we understood the concept on one-dimensional array, two-dimensional array, three-dimensional array, and four-dimensional array as well. Next to the concept of indexing, we started slicing. How we can slice an array object, we understood. So as part of slicing, we have understood it on 1D, 2D, and 3D objects, 3D array objects. Clear? So this is what we have covered today, and we'll be taking our discussion to the next level in the next class. Okay. So let me shift the gear. Right. So yesterday we have understood the demo for the internship, right? So what exactly is internship means and what are the phases that, the internship that Nextera Unitech is providing. So that is what we have discussed in the last session and as part of the orientation. Okay. So I'm here to discuss about the internship orientation session today where we'll be understanding the phases one more time and then I'll explain you how this internship is going to be part of it. Right. As part of internship, we'll be having two phases, guys. One is learning phase and the other one is the project phase. Okay. So what you will be doing in learning phase and what you are going to do it in project phase is, so initially every one of us, whoever is part of the internship will be learning the core concepts. Like what are the concepts that we'll be learning are Python, one of the fundamental skill, okay, that we are going to get as part of the internship. Next to Python, we'll also parallelly focus on SQL, structured query language, and next to SQL, we'll also focus on Power BI, EDA, and data cleaning steps. So what exactly these mean? When you are given with the raw data, okay, when you are provided with the raw data, how you are supposed to do the analysis. That analysis part you will be learning from EDA and next to the EDA we will understand the cleaning steps. When you are given with the data, how you have to clean the data can be understood from data cleaning topics. So this learning phase will be for 30 days, guys. Okay, so by 30 days, you are going to learn the concepts of Python, SQL, Power BI, EDA, and followed by data cleaning. Okay, So all these skills you are going to gain from by 30 days. How? What is the process? How you are going to learn this is, first of all, if you want to be part of this internship, you'll be provided with a Google Classroom. A link will be shared, and this is of a Google Classroom. Okay, so you have to be part of this Google Classroom. The reason why you have to be part of the Google Classroom is the communication between you and us will be happening only in the Google Classroom, and we'll be sharing the Google Classroom link here. Do be part of the Google Classroom if you want to be part of our internship. Okay, on daily basis you'll get the updates. Okay, so what happens next to being part of Google Classroom? See, even if you observe the chart, yes, we have posted the link for the classroom. I want every one of you to be part of it. If you are actually interested, if you don't want to miss out the opportunity, utilize this opportunity, guys. Just click on it. This is the invite link. You will be redirected to the Google Classroom batch 6. It will be of batch 6 Google Classroom. Once after being part of it, you'll get daily updates from tomorrow. Okay, you'll be provided with a session links document. Okay, a document will be provided tomorrow itself. On the day one, you'll be provided with a single document, and this document will contain the links related to all these particular courses from day 1 to day 30. This will contain the links from 1 to 30. Okay, so what you have to do on daily basis, you have to go through the sessions and make question and answers, right? So at least 5 MCQs, 5 short answer questions, and 3 coding questions. If they are applicable, yes, you have to come up with 13 questions for each topic. For each and every topic, you have to come up with 13 questions minimum. Maximum, we are leaving up to you. Okay. So on daily basis of these 30 days, we'll be connecting over a meet. Okay. So from tomorrow, we'll be connecting in a session and we'll be discussing. So that will be a revision session where a mentor will be provided for your batch. Okay. So this mentor will be initially recapping the important points. Whatever the important points that we have discussed in these sessions will be revised for at least 5 minutes. And then you'll get a turn to explain each and every question that you have actually documented. So this will actually focus on your communication as well as your presentation skills, which are very mandatory in the real time. Okay, so these are very mandatory because majority of us, we are not good at communication. So we have emphasized on it to focus on the communication and the presentation. We have added this particular point to our, internship program. So every one of you will get a chance to explain about your question and answers, whatever you have framed, okay, with respect to the topic, and this will be done for 30 days. Post completing our learning phase, whoever does it properly, okay, you'll be moved to the project phase, guys. As part of project phase, you'll be assigned with a project. You'll be assigned with a project, and again a mentor will be given to you. So here, whatever you learn in your learning phase, you're going to utilize those skills, okay, and complete your project, where we'll also include machine learning and deep learning in your project. So the mentoring will be done but no spoon feeding is not, you cannot expect spoon feeding as part of your project. So this is how we have designed our internship. And my suggestion again, your, you know, whatever you are trying to do, utilize this opportunity. Utilize this opportunity, guys. So let me show you the classroom once. So this is the Google Classroom that you will be redirected to. You should be part of this Google Classroom, guys. Okay. So once if you be part of the Google Classroom, you're going to get all the updates here from tomorrow. And let me also show you the document that we are sharing with you. Okay. So this session links document will also be provided. Okay. So on day one itself, when you click on this link, it will redirect you to a session, a video that you have to watch. And next to watching the video, you have to frame the questions that whatever we have discussed. Okay. From tomorrow, we'll be connecting on daily basis and we'll be discussing recapping. Okay, it's a revision session. In fact, it will be a revision session. Okay, whatever the important points that we have discussed as part of the session will be recapped one more time in our meet. So be part of the session. I mean, be part of the classroom. Only if you be part of the classroom, you'll get all the updates. If you're not part of the classroom, the updates will not be, you'll not get the updates in short. So it's time for our questions. Any questions related to your, you know, yes, if you have any kind of queries, yeah, you can contact to the number that has been provided. Your queries will be resolved, guys. So don't hesitate in asking questions related to the internship program as well as the concepts that we have understood with respect to slicing, indexing and advanced indexing. Any questions on the topics that we have understood today? And if you find that the session went well, do hit on the like button, encourage us, and also share across your connections. Share among your connections so that they'll start learning the Python, especially Numpy module, right? Any questions? Once again, it's a request from our side. Do hit on the like button. Encourage us, right? We are coming up with some amazing content, right? So encourage us by hitting on the like button and do share across your connections. If you have any questions, post them in the chat box. Utilize this time, guys. The feedback link has been provided. Please provide your valuable feedback before you leave and ensure that you have subscribed to our channel as well as have liked to our video, the session. Thank you guys. Thanks for your interactive